We want to get to the demo.
But we are now recording.
Sweet. All right, so this is automated spear twishing. Really quick background, my name is Sean Palka. I also go by Punk AB, Punk, whatever. People may know me from other conferences. I'm currently doing my doctoral research at George Mason University, which is kind of where this came about. I'm also a full-time pen tester, avid Diet Mountain Dew addict. And if you want a Twitter account, I've got a couple, as you'll see. The tool I'm going to be demoing, you can download it there. Later on, I'll send around the link as well. Feel free to play around with it, tweak it, do what you want with it. So some background on what we're talking about today. I was asked to look into smishing, which is basically phishing using SMS, and also recursive URL shortening. Don't worry about that. They didn't really pan out as research topics, mainly because it costs money, and I'm cheap. I also don't like texting, which is kind of odd to say in public. So I started looking at Twitter instead. So spear phishing, hopefully everyone's familiar with spear phishing. Otherwise, I can shoot you an email later if you'd like. Spear twishing is targeted phishing using Twitter as the communications medium. Essentially, it's the same thing. We're trying to get people to click on links, which is pretty easy, right? But we want to better exploit trust relationships and also take advantage of some human behavior. And we also want to be able to better track who is responding. So instead of these broad sweeping, everyone gets the same email, hopefully someone falls for the bait. So we're going to take this from an attacker's perspective, obviously. But the point behind this, as with most things, is I'm not trying to be mean or point out flaws in others. I'm really concerned with people being aware of social media and the types of things that people are exploiting in them. Specifically with Twitter accounts, people are accustomed to clicking on these shortened URLs. Now, if you notice, that's not the case in emails. If you send a shortened URL through an email, it'll likely get flagged as phishing. So we have two kind of communication mediums that deal with this type of content differently. Unfortunately, people are in the habit of clicking on these links now, and they don't really know what they're pointing to. You also have lots of anonymous connections using pseudonyms, like Punk AB. Who the hell knows who that is, right? But people follow random people that they don't really know who they are. And that results in really easy targeting, and it's really hard to block all the malicious people out there because they'll just create a new account and you won't know who they are. So here's a typical twishing attack that came into my account. So we got this email or this tweet that came in. It's just a tiny URL targeted at me. Well, obviously I'm going to look into who this person is, and I started doing searches and I found all these other accounts that had similar naming schemes. Started looking into them. Clearly I'm not going to click on anything that this guy sends me. All right. But he's also not trying hard enough. His profile has a very suspicious naming scheme. It's got this random string of characters at the end, so you kind of realize all of a sudden that, hey, he's probably got tons of these accounts out there. All of his tweets were the same format, so it was just an @ reference and then a URL. And so I started thinking we could probably do better, basically to make this guy look like an idiot anyway. So to do that, we need better fake profiles. We want a better way of automating tweets, and we want to develop some way of exploiting trust relationships. And then again, we also want to try and avoid detection, because if we're doing this on a focused level, we don't want to get all our accounts blocked and then have to start over from scratch. Most of the time, these bogus accounts you'll see on Twitter are not very creative. They'll be like the guy we just mentioned. The usernames are involving these random strings. They look suspicious, fairly easy to catch. Their tweets tend to be very repetitive, just like this guy where he's tweeting out a URL each time. And if you go to his profile, it's just a bunch of tweets of a URL. With spear twishing, we don't want to rely on these generic mass targeting measures. We would really want to try and focus it in. And so the first thing we need is better fake profiles. To create a profile, obviously, you need an email address. Well, Twitter blocks or auto-flags some domains, but not Gmail or Hotmail. So if we can create a Hotmail account, we can create a Twitter account. So the general process is we'll create a bogus Windows Live ID, get a Hotmail account, register a Twitter account to that email address, and then create profile contents. Blah, 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 profit. So this is an example of a block domain. It's actually a pretty useful tool. It's fakenamegenerator.com. So it'll actually build out all of the contents that you would need to create a fake profile, name, address, things like that. And it even actually provides a fake email address. And they've got an interface where it'll actually handle email coming into that account. Unfortunately, teleworm.us, if you create a Twitter account with that domain, your account will auto-flag. You won't be able to send any tweets. Windows Live, on the other hand, I guess, feels that's not so much of an issue. So you can go into Windows Live ID, fill in contents from the generated random profile, and it'll create a Hotmail account for you. So here's an example of just a bogus account I set up. Ideally, no one would trust this account, but we'll see if they do. So once we have that process down, we can go through it as many times as possible. The key is we only want to create accounts as needed. A lot of people make the problem of wanting to generate out hundreds or thousands of accounts, and then they fall into the same problem of everything's predictable because you're doing the same thing over and over again. In our profile names, we want to avoid random character strings. We want to try and use realistic names as if someone were creating the account with a name that they like rather than Curly Crawford random string of characters. And what I found is useful is to actually fill in generic tweets between those fake accounts. So I'll create 2 bogus accounts, and I'll actually send tweets back and forth between them. So if someone actually goes to the profile, they're saying, hey, they're actually sending communications back and forth with some other account rather than just spamming out links to external sources. So the next question is, how do we actually automate these tweets? And what we're going to do is we're going to use Twidge plus generative grammars. So Twidge is a command line Twitter client. If anyone's used it before, it's very flexible. You can actually create a bunch of profiles, Twidge profiles, and randomly pick between them. So it's great for our part where we want to actually pick which account we want to send our tweets as. Creating the actual feed, the Twitter content, is a little trickier. So we want to avoid these repetitious, here's a URL, try and click on it kind of tweets. I'm saying tweets a lot in this presentation. I'm not sure I like that. Since we only have 140 characters to work with in Twitter, and it's essentially like a text message, we're going to use a small generative grammar. And for those of you who don't know what a generative grammar is, basically what we're dealing with is a context-free grammar, and I'll give a quick explanation of that as well. It's very straightforward, it's compact, but it has this ability to grow really large. So a context-free grammar can actually get polynomial growth, and so even a small one will provide sufficient randomization for our tweets. We still need to be a little clever when we're designing these things, though. So this is a general kind of overview of a context-free grammar. We have a left rule and a right rule. You may have seen these before, so I have the letter A, and I can replace A with BC, and I can replace the string B with some other substring. So we go through these rules, and we can apply them, and we end up with these final strings. Well, we can start branching things out, and the left rules can go to multiple right rules, where A could go to B or A could go to C, and we get a larger number of possible end strings. And eventually, when we start building in a lot of these combinations, we see a lot of growth in the ability to create random content. So here's a little sample I wrote up, just creating random context-free grammars and tracking how much growth we got out of them over a certain amount of time. So if we're looking at just applying like three rule substitutions, once we provide a certain number of combinations and subtokens, we get a massive spike in the amount of randomness that's being created in these end strings. To give you a visualization, up top, if we have no branching and no combinations, if we start with A, we always end up with the same thing. If we start branching things out and providing some choices for it to make as far as which rules to apply, it starts to spiral out and get a lot of randomization just over 3 iterations of rules. So talking about languages like that abstractly is kind of ambiguous. It's hard to figure out what we're trying to do here. So here's an example of how we apply that to building a tweet. So we've got our left rules and our right rules, and we're actually applying it to the English language. So you can see we start with something, and we can go to either saying, include a list of targets, then followed by a statement. Or we could include a list of targets, and then follow me for some content. And then each of those variables get interpolated across rules, and we end up with this final sentence that doesn't have any rules that can be expanded anymore. Fairly easy to come up with these. It's very, very condensed, but you'll notice that at each of these choices, you get a lot of different randomization in the tweet that ends up being built. Another key thing we can use is feedback from Twitter itself. So when you actually go to Twitter and click on someone's profile and see who's following them, for example, Twitter sends back a lot of useful information to you. It includes like recent tweets that they sent out. It includes pound references that they had. And we can use all this to kind of apply it to our context-free grammar and include these references in the content that we're going to be sending out. We can also take older tweets that were sent out, and instead of using the URL reference that they had in them originally, we can simply replace it with our own. What we'll do is we'll basically replay that tweet and hope someone mistakes it for the original sender. The question now is we still need to worry about who we're targeting. So remember, we're dealing with spear twishing here, so we don't want to just randomly go across Twitter and find random accounts and include them in a target string and hope they fall for it. So we're going to take a look at some of the trust relationships that occur in Twitter. So people trust the people they follow, roughly. They wouldn't follow someone if they thought they were malicious and going to send them tweets that they wouldn't want to click on. But you're also connected to the people who are following you because there's some inherent trust there as well. So what we want to look at is all of these trust relationships between followers and followees and trying to find connections between them. Obviously, Twitter lets you do this through their interface or all the GUIs you can go to. But it takes a lot of time to start clicking through that and mapping out, okay, this person is following this person who follows this other person who may have a connection with this other person. So I wanted to do that in a more efficient manner. And the problem we have is large graphs. Some of you may have used Maltego before. Excellent tool. When you start using Maltego to map this sort of relationship, you end up with the same kind of problem where it's just really tough to figure out what Maltego is trying to tell you. So you end up having to build all these complex filters. What I wanted to do was build it from a more sparse graph and build it up as needed. But to avoid the problem of large graphs, I went with hyperbolic trees. So think of this as looking at the graph through a fisheye lens. So the center of the graph is a bit larger, and all the nodes on the outside are more condensed because they're not really the focus of what we're looking at. And ideally, I wanted to take this and be able to browse through it and maybe expand out to other parts of the tree. And there's a great tool set out there. I think it's called the JavaScript Data Visualization Toolkit. Excellent open source software. So they actually had a hyperbolic tree implementation that I kind of tweaked. And so what we can do is we can start looking at connections between people on Twitter. So this is an example of my account and some people that are following me and how they're connected as well. And this is what we're looking for. Because we know from this graph that I have a connection with 2 accounts that are also connected. So I can start sending communications to those 3 accounts referencing the other accounts, and it looks like I know something about them. Or I can try and include all 3 of them, and it looks like I'm just forwarding information that's relevant to everyone. So the next question we have is tracking responses. We can use various URL shortening services like Google, and they usually provide some sort of, here's how many people have clicked on your URL. It's not quite that simple when we're trying to actually, determine whether someone's been caught by our attack. And we also want to avoid some of the more common ones like Google. They tend to get all like iffy and paranoid and start flagging things as suspicious. So we wanted to find one that doesn't do that. And of course, what we'll see are the responses from these shortened URLs are interesting as well. So I went with shorturl.com. It's got a web interface. You can drop in a link. It'll shorten the URL for you, and also provide this status page that you can go to. So it lets you track how many raw hits or how many unique hits have come to that shortened URL. One thing I noticed, the second I tweeted out one of these shortened URLs, I immediately got hits. At first I was like, yay, people are instantly falling for this stuff. Not so much. Turns out these are bots, or spiders, or whatever you want to call them. Ziggy played guitar. Anyone get the reference? Spiders from Mars? Oh, sad. One of the interesting observations I made from this is that just shortening a URL, there could just be random people going around and checking to see whether a shortened URL is valid or not. Or it could be these bots that are just trolling the internet trying to find valid shortened URLs. But interestingly enough, the second you tweet one of these shortened URLs, I guarantee you will get people requesting that resource. And for some reason, I thought this was kind of rude. I mean, it's kind of like auto-scanning something without consent. So I started thinking whether I could target these bots. So the first thing I thought of was maybe I can get them to recurse and just start spinning their wheels, right? So I'm going to shorten a URL and point it to page1.html. And page 1 is going to point to page 2. Page 2 is going to point to page 1. And it'll just cycle back and forth. If you do this in a browser, you'll basically sit there and reload pages over and over again unless you're caching. So the question was, would the bots go down this rabbit hole and just start spinning their wheels? The other question I wanted to see was whether we could use this as a magnification. So I point the bots at page1.html, which contains a bunch of iframes, to other pages, which contain a bunch of iframes, to other pages. And eventually, down at the end of the line, we point them at a target. So we would see one request resulting in a larger number of requests pointing out to some external resource. Sounds great, right? No, didn't work. What we found was that the bots don't appear to do a deep dive on these resources that are that you're shortening to. So if I shorten a URL to some page, subtest.html, and we have the following HTML source, where it's just an image. We shorten a link to that, post it on Twitter, we automatically get responses. But these are the kinds of responses we get. And the question mark shortened, that's me. I put that in there just so I could sort it easier in the logs. You'll notice something odd about this. Nobody has requested the picture. They're just requesting the page. One was kind enough to request robots.txt and then just basically ignored it later on anyway. But none of these are actually requesting the image. And that looks like a filter to me. So what we'll use is our first page as a filter to catch all the bots. And then the actual resource we want to track as either an iframe or some other sub-element. So when we get requests for actual page.html, we know it's not coming from these bots. So we can assume it's probably from a person. So then we can start figuring out whether our spear twishing attack actually worked. So we have fake profiles. We can generate our tweet contents. And we can start to visualize some of these trust relationships to build a target list. And we can loosely track the responses, assuming we can identify these bots. And here's how we're going to measure success. If people follow us, we win. Because you have basically gained their trust, and you can tweet things out to them, and they might click on links down the line as well. If people click on a link that we send, again, we win because we've got them at a resource that we control. If anyone doesn't think that's dangerous, I invite you to go talk to David Kennedy later. If people retweet our links, again, we win as well. It's the same sort of situation as forwarding a malicious email to someone. That email gains the trust of the person that is forwarding, so people who trust that person now trust that email a little bit more. So the question is, does it work? This is like one of my favorite screenshots ever. So some backstory behind this. At DEF CON, I was on one of the mystery challenge teams, and social engineering is a pretty big component in that contest. So what I did was I actually created a bogus account that mirrored Lost's profile. And I just started retweeting everything that he sent out. As it turns out, it was higher up in the queue. Like if people were tracking a lot of people, mine would show up more recently than his original tweet. And at one point, Dark Tangent actually retweeted my fake tweet. And I ended up getting a lot of followers to this account. So then we were able to send out bogus information about the contest and get lots of neat points. So let's do a demo. And hopefully the demo gods will be with us today. So really quick, here's an example of building some good profiles. So this is Lost's account. And this is the account that I mirrored. So you notice it's, at first glance, very easy. But just creating random accounts, we want to provide at least something that's tempting to people. We want to make it look like someone put some effort into creating this account. Here's one of the accounts I created called Zombie Fighter. Ironically, I did not create that just for this conference. I don't know if that's sad or good. So here's the tool. They call it HyperTwish. And again, you can download it. I'll be sending out the link later. What we have is our original map of who's following some account. So this is my account. You can change the interface. You can include lines or arrows. You can switch between followers and people who they're following. And so you start to see these graphs growing a little bit bigger. If you want to focus on one area, you just click it and it redraws the map so you can focus on a different part. As it's going through, it's keeping track of who is following the node that's in the center. So you can add more people or you can remove it. So we could go through and actually remove DEF CON parties, right? And it creates less traffic in the map. If I want to expand one a little bit more, so let's say I hack stuff, we'll add more followers to that. Right. So that one got expanded a little bit more. And what we're looking for are these connections like this, right? Where you've got like a triangle. There's some level of trust between these three users. So let's actually, instead of using my account, let's have some fun. Okay. This Twitter account should look familiar. So what we'll do is we'll add some more followers to this account and see if we can start finding some of these connections. All right. We'll add followers to Dave Relic. Right. And now we start to see a lot of these connections, right? Because Dave is a very popular person. So once we have something in the graph that we want to look at, we'll add them to a target list. So we'll add these three. So the next step is to actually build some tweets against them. So this is basically the interface to the generative grammar that we wrote. I've got a couple different schemes in here. So, for example, if I just want to write a normal tweet and don't want to go by anything that's pre-built, there's a follow me kind of scheme where, hey, don't mean to interrupt you, but would you mind following me? All the way down to something where we're referencing previous tweets that were sent out or interest that we've developed from looking at their previous tweets. So you can see Hack3rcon was one of the pound references that were used. Again, if we're not satisfied with what we have here, we can regenerate everything, and we get different contents. So again, that's the randomization that's resulting from using a context-free grammar. We're not tweeting out the same thing every time. For shortening the URLs, we can actually go over here. Let me show you this other interface first. Once we tweet out, we're going to actually be tracking these things through the shortening service, but we're also going to go a step further and actually look at the HTTP logs, because we want to start parsing out whether these are bots or whether they're actual victims. For the bots, I ran some tests, so I know certain domains that are basically bots. And also in the user agent, if you see things like JSKit or tweet meme bot, you can exclude those as well. So what we're going to do is we're going to send out to this contest URL. And we'll just see what happens. Then we get to pick which account we want to send it as. So these are a couple bogus accounts that I've set up. Not really using them to attack anyone, but I've also got my normal Twitter account in there as well. So since it's Hack3rcon, we'll use Zombie Fighter to send things out as. Right. So now it goes through and it uses Twidge to actually post the tweet to the internet. See if it actually posts. The demo gods are not happy. Right. Let's see if we can demonstrate just what happens when you send out an alt URL. That's right, it's Verizon. So you'll notice I don't have any raw hits or unique hits here from the shortening service. And one thing I wanted to show is how quickly this happens as far as actually getting responses. Once I send this out, I already have 6 hits from 4 unique sources. I know these are bots because, first of all, no one's going to be that interested in a random link that I just sent out. But we can also parse through the logs and start tracking where these URLs are actually coming from, like where the requests are coming from. And so you can see the ones that requested this contest URL all are like unwind fetcher, tweet meme bot, JSKit. We got another hit from those. And we can exclude those. But notice we didn't include any new victims because we didn't catch anything that met our profile. If we start targeting people like, with @ references, most likely people might click on something. And unfortunately, Twidge is being a little whiny today. Anyway, so that is HyperTwish. It's a pretty useful tool. I've thought about using this for a couple different things on pen tests. So far, no one's agreed to let me target their Twitter accounts yet. So, if you're interested in looking at it, I can walk you through some stuff later, and I'll tweet out the URL. Or actually, I'll probably have Bill do it, because why would you trust anything that I tweet? Right? And that's it.